In this lesson, we are going to combine our shoe lesson for solving linear equations and our balance beam for solving linear equations together to find a more practical and easy way of solving linear equations. So the first two are just to show you guys and develop an understanding of what's happening. Now this one we're tying everything together to show us how we solve. So I'm going to start with my first question here. So I'm going to have 3 over 4x is equal to 9. Okay? So I look at this here. If we were to do the shoe method, that's saying we're starting with x, right? And we are multiplying x by 3 over 4. And that's going to give me 3 over 4x. Now we're saying that is equal to 9, because that's this whole side here. Now we must do the opposite to solve for x. So I'm going to divide 9 by 3 over 4. Okay? So if I look at that here, now remember what we learned from the balance beam. So here we did the shoe method. Now we're going to apply this shoe method to our equation using the balance beam idea. So what we had to do on one side, we always have to do to the other. So on this side here, we're dividing this by 3 over 4. Okay? So that means I must divide this here by 3 over 4. Okay? So 3/4 divided by 3/4 is 1. So that's just going to leave us with 1x. We don't need to put the 1. And now we're going to go is equal to 9 divided by 3/4. So let's look at this here. We know how to divide by fractions. We leave this the same, leavey samey, change the sign, changey wangey, and uppy goes downy. So that's going to give me 9 multiplied by 4 over 3. So this is essentially same as 9 over 1. So we're going to go 9 divided by 3 is 3 times 4 is 12. So in this case here we get x is equal to 12. So when we do this, 9 divided by 3 over 4, we get 12 right there. So essentially we combine both the balance beam method and the shoe method in order to solve this and make sure we do it in a proper way. Eventually you might not be using either the balance beam or the shoe method, as you'll just be writing it out this way, which is faster and more efficient. But I strongly encourage you to use the shoe method to help you with this balance beam. Remember, doing both sides, what we do to one must do to the other, to help us out. So let's look at my next example. Okay, so let's take a look at this one here. We're going to have 2 over 3x plus 1 over 5 is equal to 3/5. So same thing, we're starting with x here. What's the first thing we're doing with x? We're multiplying it by 2 over 3. So I end up getting 2 over 3x. Okay? Now, what are we doing? Next is we're adding 1/5 if we're following BEDMAS. So I'm going to go plus 1/5. So I get 2x over 3 plus 1/5. It's a bit sloppy there. Okay. So this is equal to 3/5. So now let's look what's happening here. First thing we want to do is subtract 1/5, do the opposite operation. So we're going to subtract 1/5. That's what it says. So we're going to subtract 1/5 from both sides. Okay? So we're going to get 2 over 3x is equal to, well, what's 3/5 minus 1/5? That's going to give me 2/5. So there we did. We used our balance beam method combining with the shoe method here. Balance beam, what we do to one side must do to the other. So we're left with 2/5. And that is true here. If I look at this, we're saying 2/3 x is equal to 2/5. 2/3 x is equal to 2/5. So my next step is I must now divide by 2 over 3. So I'm going to divide both sides by 2 over 3. Divide by 2 over 3. So I'm left with x here is equal to 2/5 divided by 2 over 3. Because 2/3 divided by 2/3 is just going to be 1. It's the same number divided by itself. Now once again we have to follow my division rules with fractions. We leave this the same, leavey-samey. Changey-wangey, change the sign, and then uppy goes downy. So here, these 2's cancel each other out, because 2 divided by 2 is 1, and then we have 3/5 is my answer. So I can just extend that. 2 divided by 2 is 1, and we have 3/5. So we get x is equal to 3/5. All right? Let's take a look at my next example. So for my next example, we're going to look at decimals here. I have 1.2x minus 0.7 is equal to 10.1. So we're going to do the same thing here. We are looking at x, right? Let's look at our shoe method, starting off with our shoe method, and then we're going to apply our balance beam. So x, what's the first thing we're doing to it? We're multiplying by 1.2, which will give us 1.2x, following BEDMAS. Next thing we are doing is we are subtracting 0.7, which gives us 1.2x minus 0.7. Okay. Now, we know this here is equal to 10.1. So what's the first thing I must do? First thing I must do is add 0.7. So I'm going to add 0.7 to both sides, because that's what we learned from my balancing beam. We add 0.7 to both sides. All right? So I'm going to end up getting, well, 0.7 negative plus 0.7 will just give me 1.2x is equal to 10.8. So we have 10.8 is equal to 1.2x. This here is showing the same stage as this. Now my last step is I must divide by 1.2. Opposite of multiplying is dividing. So I divide both sides by 1.2. So I'm going to get x is equal to 10.8 divided by 1.2. So let's see how we could do this here. If I really want to do this, divide it. Remember, move the decimal places over 1 for both, times both by 10. So we keep our proportions the same. So I'm going to end up getting 12 dividing 108. So 12 goes into 108 9 times. So then we end up getting x is equal to 9. And that is my answer. Okay. I have one more for you here that's a little bit different. So we're going to look at this here. When we have 3 over x plus 4 is equal to 5. All right. There's kind of two ways of doing this. So first of all, if I look at this, I'm going to do it first the way I do it, then I'm going to show you with the sock method. So first of all, I'm going to minus 4 from both sides, because what we do to one must do to the other. So I get 3 over x is equal to 1. Now I look at this, what do we not like x to be? X cannot be on the denominator. We don't want our x in the denominator, we want it on top. So if I want to get rid of x as denominator, I'm going to multiply this by x, multiply this by x. So I end up getting 3 is equal to x. Okay? Now the other way of looking at this, if I was to use the shoe method, is I'm starting with x. And what is the first thing I'm doing to x? I'm taking the reciprocal of x. So I end up with 1 over x. Okay? Then I am multiplying by 3, which gives me 3 over x. Then I'm going to plus 4, which gives me 3 over x plus 4. Or 3 divided by x plus 4. That's equal to 5. So first thing I'm going to do is minus 4, which gives me 1. Okay? Now I'm going to divide by 3, which is the opposite, which gives me 1 over 3. Okay? Opposite of timesing by 3 is dividing by 3. My last step here is I did a reciprocal, so I have to do the reciprocal again. So I'm going to go 3 over 1 So x is equal to 3. So I could have done it that way with the shoe method as well. It is a little bit more tricky, but you can do it that way. All right, my very last one is going to be like this, and this is one that somewhat confuses students. So let's say I have 4, okay, and I'm minusing 3x, and I'm saying that's equal to 12, okay? So once again, this is why I like the shoe method. So what are we first doing by x? First thing we are doing to x is we're timesing it by -3. Because if I look at this here, we have -3x. So it is times by -3, which gives me -3x. Okay? Now the next thing is, if I could always rearrange this, so I have -3x plus 4 is equal to 12. That's the same thing, essentially as saying 4 minus 3x. Okay? We're just combining a negative and this 4 here is a positive. So essentially what we are doing is we are adding 4 to this. So I'm going to be getting 4 minus 3x. And we know this is equal to 12. Okay, so we're going to go in reverse. First we're going to minus 4. So I want to minus 4 from both sides. So this is going to give me, I have -3x is equal to 8. So I have 8. Same steps, -3x is equal to 8, -3x is equal to 8. My next step is divide by -3. So I divide by -3, divide by -3. Remember, what we do to one side, we must do to the other because of the balance. Shoe is we go opposite a bed mass and we do the reverse operation. So we divide by 3. Well, let's look at this here. X is equal to, how many times does 3 go into 8? It goes in twice. So I'm going to have -2, and we're going to have 2/3 left over. Because it goes into twice, which gives me 6. That's going to be 2 left over. So it's -2 and 2/3 is my answer. So -2 and 2/3 is my answer. And that is kind of how we combine the shoe method and the balance beam to help us solve equations. Eventually by the end, you will probably just be doing this by the end of class, but it's good to use both of those and think of what's happening to follow an algorithm as how to do this.